next content. So I would like to inform all of you that the training course, the Zoom will be recorded and will be uploaded to YouTube via Cbwm web page. So the next session is the course content for the course. Okay, so today, Monday, 7 November, we will go through Thailand measurement system about 1 hour and 30 minutes. For briefly introduce of Cbwm type approval, reference standard, traceability and registration regarding Coriolis Flowmeter. In the afternoon session, for the first hours after lunch break, Mr. Kampana, one of our trainers, will walk you through the construction of Coriolis Flowmeter, where you will be introduced of its history, Coriolis effect, and its theory of operation and typical construction of the flowmeter. After that, the trainer will bring you to know more about basic concepts of designing and selecting and its performance and limitation of working of the Coriolis Flowmeter for 1 hour. Then, before closing the first day, there is 15-minute session where all of you could give us some feedback or asking questions. On tomorrow, Tuesday, November 8th, in the morning section, Marian will open the day by giving opening remarks for 15 minutes. Then the trainer will give you knowledge of installation and maintenance and influence quantity. Then Mr. Sutik, another trainer, will introduce you calibration method, where you will be introduced dry calibration, wet calibration, and density calibration before lunch break. And in the afternoon session, he will then guide you how to verify Coriolis Flowmeter, both visual inspection, verification process, sealing, verification mark, and document. Then we will wrap up everything we learned from 2 days together, along with open for your questions, feedback, and comment before completely closing the course by 3:30 p.m. So during the course, you will have me, you can call me Benji, for facilitator along the course. And we also have Miss Marian here to support us during the course. We also have our expert in Coriolis Flowmeter, who is Mr. Philip Gerling. And so if you have any question regarding Coriolis Flowmeter, you can ask via Zoom chat box or ask during the session. So next session will be the course material. I would like to inform all of you that all training material were put into the PTB box. You could access the box by clicking the link that I show in the slide, and I will send you via Zoom chat box. Okay, so currently training material consists of 2 items, so I will show you now. This is the link, so I will send you to the Zoom chat box. Here is the link. So when you click onto the link, you will see now we have consists of 2 items. So the first item is the notification of the Ministry of Commerce regarding prescription of type and characteristic of direct mass flow meter, the detail of material used for manufacture, maximum permissible error, and term of verification. This document is from Thailand government, and this document established in 2019 based on OMLR 117. However, this document is an official translation because some technical word might not be the correct one. However, it will give all of you some clue of our legislation regarding Coriolis Flowmeter. The second item that we put into the PTB box is presentation from trainer, which will be used along this training course. You can download each individual file by double-click at the name of the file, or download all file as a zip file by clicking on download button here on the top of the page. If you have any questions or problem regarding training material, please feel free to send me a message via Zoom chat box. Okay, so now it's 9:30. I think it is a time to take a group photo before taking 30-minute coffee break and moving on to the next session. So please turn on your video camera. Okay, so everyone turn on your camera and so we can see your face. Okay, so are you ready? Okay, 1, 2, 3, say cheese. Okay, one more. Okay, 1, 2, 3, say cheese. Okay, thank you. So I will give you a 30-minute break and we will come back around 10 a.m. Bangkok time. Thank you.
ความจริงเนี่ยมันคิดไม่ได้คืองานมันขึ้นแบบร้อง รหัสของฟ้า
Okay, everyone, welcome back to the next session. Okay, so I will begin with the Thailand measurement system session. So this session, I will briefly introduce you our measurement system. This session consists of topic of Cbwm. What is the Cbwm stand for? And the next one is the Thai approval and reference standard and traceability and distribution. So what is Cbwm? Cbwm stand for Central Bureau of Weight and Measure. I will show you the video clip that give you briefly introduction about Cbwm.
เรื่องชีวิตกับช่างตวงวัดในอดีตเรื่องชีวิตกับช่างตวงวัดในอดีตเมื่อไทยเริ่มมีความเจริญทางการค้ากับต่างชาติมากขึ้นแต่ยังขาดมาตรฐานการช่างตวงวัดที่มีความเป็นสากลพระบาทสมเด็จพระจุลจอมเกล้าเจ้าอยู่หัวรัชกาลที่ 5 ทรงมีพระราชปรารภให้วางระเบียบการช่างตวงวัดให้มีมาตรฐานตามระบบมาตราสากลเพื่อให้เกิดความเจริญและความสะดวกในการค้าขายจนมาถึงปัจจุบันชีวิตทุกๆคนยังคงเกี่ยวพันกับการช่างตวงวัดอยู่ตลอดเวลาเริ่มตั้งแต่เช้าการหุงข้าวต้องมีการตวงข้าวและน้ำเครื่องปรุงต่างๆก็ต้องบอกปริมาณซึ่งกำกับไว้ที่ภาชนะและของใช้หลังจากตื่นนอนเช่นยาสีฟันโฟมล้างหน้าแป้งทาตัวก็มีปริมาณกำกับไว้อย่างชัดเจนส่วนกระสอบอาหารสัตว์มีขนาดบรรจุแจ้งเป็นกิโลกรัมแม้แต่เชือกล่ามควายก็ต้องซื้อมาใช้เป็นเมตรเช่นเดียวกับผ้าและสายไฟต่างๆนี่ข้าวเปลือกตั้ง30กระสอบรวมน้ำหนักถึง900กิโลกรัมที่จะนำไปขายน้ำมันใกล้หมดต้องแวะปั๊มเติมน้ำมันกันก่อนดูนี่ระบบการเติมน้ำมันเชื้อเพลิงที่ได้มาตรฐานสังเกตได้จากตรารับรองจากสำนักช่างตวงวัดกรมการค้าภายในจึงมั่นใจได้ว่าจ่ายมาเต็มลิตรไปต่อกันเลยถึงแล้วในระบบการคิดราคารับซื้อข้าวมีการคำนวณน้ำหนักข้าวและค่าความชื้นร่วมด้วยแต่ถ้าพบความผิดปกติเกี่ยวกับการช่างตวงวัดให้รีบแจ้ง1569ทันทีเพื่อความเป็นธรรมและถ้าตรวจสอบพบว่ามีการทุจริตจะมีโทษตามพรบทั้งจำและปรับที่ตลาดก็เช่นกันถ้าตราช่างได้มาตรฐานผ่านการรับรองของสำนักช่างตวงวัดกรมการค้าภายในมั่นใจได้ว่าน้ำหนักถูกต้องไม่ต้องกลัวความผิดการค้าโปร่งใสเป็นธรรมทุกฝ่ายมั่นใจค้าขายกันอย่างมีความสุขสำนักช่างตวงวัดกรมการค้าภายในมีหน้าที่กำกับดูแลผู้ประกอบการธุรกิจเพื่อให้มีมาตรฐานและเป็นธรรมแก่ผู้บริโภคทุกคนสำนักช่างตวงวัดกรมการค้าภายในกำกับดูแลเครื่องช่างตวงวัดที่มีการใช้ช่างตวงวัดสินค้าและใช้สำหรับการบรรจุสินค้าหีบห่อเพื่อการซื้อขายไม่น้อยกว่า5 ล้านบาทต่อปี มีข้อสงสัยสามารถติดต่อสอบถามได้ที่สำนักงานกลางช่างตวงวัดกรมการค้าภายในหรือ www.cbwmthai.org
I know, Miss Einstein.
So Cbwm is one and only legal methodology organization in Thailand. While Legal Methodology Act of Thailand is called Weight and Measure Act. The act is established since 1999 and revised to the current edition, which is third edition since 2014. In this act, as I mentioned before, Central Bureau means Central Bureau of Weight and Measure, while Branch Bureau means Branch Bureau of the Central Bureau, which include both regional center and their branches. So the Central Bureau of Weight and Measure in the Department of Internal Trade under the Ministry of Commerce has the authority to keep and maintain reference standard of measurement, to issue a business license and permit, to inspect and verify weighing and measuring instrument, to register personal mark of the business holder, and the last one is to perform any other act as provided for. So as you can see from the slide, yes. You can see that we are under the Department of Internal Trade with supervised by Ministry of Commerce. They also have a weight and measure committee to consult us. We supervise, we have 4 regional weight and measure center, and we supervise 28 branches, cover 77 provinces for approximately 66 million people of Thailand. In the central part of Thailand, there is Cbwm, located in Thailand provinces. As you can see in the list, in the red rectangle, the Central Bureau supervises 7 branches, cover 18 provinces, as you can see in the orange circle in the middle part of Thailand. This area is the central business area where most of spring scale manufacture, with approximately 13 manufacturers out of 15 of spring scale manufacturers located in this area. There are 4 big fresh markets in this area where most of spring scale and digital scale are found. In Thailand, spring scale are produced about 500,000 to 700,000 each year, and it is traditional scale in sale and exchange edible products such as vegetable, fruit, fresh meat, and seafood in any level of fresh market. The next part of Thailand, the northern part. In the northern part, there is Northern Weight and Measure Center located in Chiang Mai province. The Northern Center supervises 7 branches, which cover 17 provinces, as you can see in the orange circle in the northern part. This area has many cold weather food and vegetables for exportation. Currently, the Northern Center and its branches are now supervising Longan grader in the northern area. The center is now setting up laboratory for testing the refractometer and currently studying to draft regulation for the refractometer and wood moisture meter. The northeastern part of Thailand. There is Northeastern Weight and Measure Center located in Khon Kaen province in the northeastern part of Thailand. The center supervises 7 branches cover 20 provinces, as you can see in the orange circle. This area has the most various type of rice and rubber tree in Thailand. Currently, the Northeastern Center is now studying quality of rice, measuring instrument, apart from rice moisture meter, that is regulated one. They also have a percent of starch measuring instrument for tapioca being used in this area. And this type of instrument has registration also. The southern part of Thailand. There is Southern Weight and Measure Center located in Surat Thani province. This center supervises 5 branches cover 14 provinces. As you can see in the orange circle, this part of Thailand has a lot of palm oil and rubber tree. This area is currently studying percent of dry rubber content measuring instrument to drafting related regulation. Truck scale in this area mostly used in weighing palm oil, and the spring scale are widely used to weigh rubber cup. The last part of Thailand, the eastern part. There is Eastern Weight and Measure Center located in Chonburi province. The center supervises 2 branches, cover 8 provinces. As you can see in the orange circle, this part is the smallest part of Thailand. But there are many oil refinery farms, the oil depot, and important port area located, such that large size of flowmeter and weight in motion scale are mostly found here. Coriolis mass flowmeter, fuel dispenser, LPG dispenser, and NGV dispenser are mostly found here apart from Bangkok metropolitan. The next session, the Thai football. According to the Act, for scope of weighing and measuring instrument under this Act or regulated instrument are all kind of weighing instrument and all kind of volume measuring instrument, except which are notified to be exempt. While measuring instrument which Minister of Commerce notified to be included is regulated instrument under this Act. So you can see from the picture that the big green circle here, the big green circle is all kind of weighing instrument and all kind of volume measuring instrument combined. While the lighter one, the green lighter one, is all kind of measuring instrument. The dark green line over the big green circle and some part of lighter circle indicate the regulated instrument under this Act, while the red line area here indicated the weighing and volume measuring instruments which are notified to be exempt. Thailand legal unit for regulated instrument is only unit in metric system. Otherwise, it should be specified in traditional unit and has to be notified. Whoever use regulated instrument in unit other than metric or traditional system in the purchase, sales, or distribute goods shall be liable to a fine not exceeding 5,000 baht, which equal to approximately $142. So, not all regulated instruments are required to be verified. This section of this act specify that only regulated instruments used in a sale or exchange of merchandise with other person or in the measurement service or for the purpose of the calculation of remunerations, tax, and fee are required to be verified by Cbwm officers. So you can see from the picture that the area, this area, only this red area is the regulated instrument. For the Thai approval, the Thai approval system in Thailand, the act indicates that manufacturer or importer who would like to manufacture or import weighing and measuring instruments that used in a sale or exchange of merchandise with other person or in the measurement service, or for the purpose of the calculation of remunerations, tax, and fee, which is the regulated instrument, shall submit type of the instrument along with supporting documents, or submit Thai approval certificate to Cbwm officer to be approved. As you can see from the picture, that Thai approval is the same as illustrated in verification, which means that group of regulated instrument that is required to be verified shall be required to Thai approval too. However, Thai approval system in Thailand has not been implemented yet. We plan that the system along with related regulation will be released no later than the middle of next year. The traceability. This slide shows the traceability chain of Thailand measurement system. The regulated weighing and measuring instruments found in the market and are used in a sale or exchange of merchandise with other person or in the measurement service, or for the purpose of the calculation of remunerations, tax, and fee are verified and inspected by reference standard of Cbwm. Here, this is the working standard that we use with traceable to the reference standard. This reference standard, we keep 3 types of the reference standard. We have the primary one, the secondary, and the tertiary. This is here, the reference standard from us. And then we use the primary standard, which traceable to national primary standard, which is being kept by NIMT. Here and here from NIMT, this is traceable to the definition of the unit defined by BIPM at the top of the pyramid. Okay, so the next session is the session that I will brief you the regulation of Coriolis Flowmeter. The registrations of Coriolis Flowmeter is specified in the notification of the Ministry of Commerce. This is the name here, the long name of the notification. So the name of the notification, the full one is notification of the Ministry of Commerce regarding prescription of type and characteristic of direct mass flow meter. Detail of material used for manufacture, maximum permissible error and term of verification. So this notification contain not only the term of the direct mass flow meter, but also the requirement of the detail of material that used for manufacture the flow meter also. This notification will tell you the maximum permissible error of the flow meter and also the term of the verification. So in this notification, the direct mass flow meter is the meter designed to directly indicate the value of the mass of the liquid or the gas in a vapor state, flowing through the meter without depending on any associated devices or data indicating property of the liquid or the gas in a vapor state at the time of measurement from the source outside the system. Actually, there is one type of the direct mass flow meter currently used in Thailand, namely Coriolis mass flow meter. The main requirement of this notification is that Coriolis mass flow meter used in purchasing, selling, or exchanging goods with other person or providing the service of measurement or using the meter for the benefit of calculating consideration, tax, and fee shall have the feature as specified in this notification, and surely it has to be verified by Cbwm officers. In case that the person wish to produce or import the meter that has the feature different from specified in this notification, that person shall inform the competent officer, which is the Cbwm officer in S1, for the verification and for the approval to be used in Thailand. The Coriolis mass flow meter shall be produced in a durable manner. In addition, it shall not be simply used as a tool of fraud. The mass flow meter shall be produced from good material. In addition, it shall be designed and produced in a manner that when it is used as usual, it can always operate accurately. And the component of the meter can operate continuously without defect, bend, or deformation which affect the accuracy of the meter. In case of adjusting the meter, the adjust meter is required to maintain the condition of accuracy appropriately. In case of necessity, the Central Bureau of Weight and Measure may test the type of the meter in accordance with rules, procedure, and conditions as stipulated by the minister on the recommendation of the committee. But as I mentioned before that now we have not passed the type approval system in Thailand yet. So maybe some type that we suspect to be used in fraud will be tested by us. The Coriolis mass flow meter shall display the following detail on the instrument. These instruments include the name and a trademark of a producer, an importer, or a seller. A model which is specified the form of an instrument, and the last one is the serial number of an instrument, which is specified by a competent officer, which Cbwm officer. All these details shall be easy to read, clear, and indelible. There are also plenty of characteristics for the mass measuring system that required for the Coriolis Flowmeter. It includes the ancillary and associated devices. The ratio between the maximum flow rate and the minimum flow rate, which is we require if in case of the liquefied petroleum gas or LPG or the gas in a vapor state, the ratio must be no less than 5:1. In case of other liquid, the ratio must be no less than 10:1. The direct mass flow meter adjustment is required for the adjusting the ratio between the display volume and the volume of the liquids or the gas in a vapor state as daily measured by the measurement system of the meter. A shortcut piping system is prohibited to be used in adjustment, and there shall be a tamper evidence seal to prevent later adjustment. The notification also require the detail for indicating device, the zero setting device, and the price calculating device. Also the quantity pre-setting device and price pre-setting device. Yes, very detailed, and you can see all of this detail in the notification that we already put in the PTB box. Here, we also have the characteristic of the printing device or the cast. This is such as the scale marks shall correspond with the indicating device. The printing of measurement result shall correspond with the result shown in the indicating device, and also the result shall be done after the measuring process is complete. And the printing of measurement results shall include the details such as the total volume of the discharge, the unit price of the product, the total purchase price, the product type indicated by name, symbol, acronym, or code, the date, and the date, month, and year of the sale. For the MMQ, the minimum measured quantity MMQ shall be determined by the producer. As I mentioned before that in this notification, we also have the maximum permissible error indicating here. So for the MPE for initial and subsequent verification, we have 3 cases. The first case, if the test volume exceeds twice as much as the MMQ at the temperature, pressure, and flow rate as specified, it shall provide both positive and negative sides of the MPE of the weight as displayed at the measuring condition or the volume of the liquid or the gas in a vapor state as displayed at the base condition conforming to the following table. So in the table, they also classify it into 2 types of the mass measuring instrument measuring system. The first type is the meter installed in mass measuring system. We call it A. For the A, if we use A for the liquid, excluding the LPG, so the MPE should be 0.5%, and for LPG it should be 1%, and for the last one, gas in vapor state, it should be 1.5%. Another category of the meter is the meter that does not install it in mass measuring system. We call it B. So if we use B for measuring the liquid excluding LPG, the MPE should be 0.3%. While for using for the LPG, the MPE should be 0.6%, and the last one for the gas in vapor state, the MPE should be 1%. The second case, if the test volume does not exceed twice as much as the MMQ at the temperature, pressure, and flow rate as specified, it shall provide both positive and negative sides of the MPE of the weight as displayed at the time of measurement, or the volume of the liquid or the gas in a vapor state as displayed at the base conditions as follows. For this case, we categorize by the meter. So the first one that we call A is the meter installed in measuring system. The MPE is the 2 multiplied by MMQ multiplied by A divided by 100. And the second category is the meter not installed in mass measuring system. So the MPE should be 2 multiplied by MMQ multiplied by B divided by 100. When A is the MPE in the table under the first case corresponding to line A, and the B is the MPE in the table under first case and corresponding to line B. The third one is the errors in repetition. The error in repetition of the mass measurement results of the liquid or the gas in a vapor state. If the test volume is no less than 5 times as much as the MMQ at the temperature, pressure, and flow rate as specified, the difference between the highest and lowest value of the test volume, which are the same as and consistent as displayed at the measuring condition, or the volume of the liquids or the gas in a vapor state as displayed at the base condition, shall have the value of weight conforming to the following table. So for the A is the meter that has installed in the measurement system. For the liquid that excluding the LPG, the error in repeat should be 0.3%, while for the LPG is 0.6%, and the gas in vapor state is 1%. And for another category of the meter which is not installed in the measuring system, for the liquid excluding LPG, the error should be 0.2%. While for the LPG should be 0.4%, and the last one for the gas in vapor state should be 0.6%. And the range of error in mass for measurement results. The range of error of the mass measurement results, if the test volume is no less than 5 times as much as the MMQ at the temperature, pressure, and flow rate as specified, its weight shall not exceed the length specified in the following table. For the A, for the liquid excluding LPG, the length of error should not exceed the 0.5%, and for the LPG should not exceed 0.5% also. And the last one, for the gas in vapor state should not exceed the 1%. While the gas in a vapor state to be used in the meter test shall be the gas in a vapor state in the same kind as the gas to be actually measured, or the gas whose physical property are close or equal to the gas to be actually measured, or the gas in a vapor state or the liquid as decided by the Central Bureau of Examination. And this table is the MPE for inspection process. The MPE for the inspection of the meter which is installed in the measuring system when in service shall correspond to the designated range in the following table. For the inspection, the MPE for the meter used for liquid excluding LPG should not exceed the 1%, while for the LPG should not exceed 2%, and the last one, gas in vapor that also should not exceed the 2%. The notification also indicate the additional characteristic for the mass measuring system in petrol station providing the LPG and the gas in a vapor state. You can see more detail in the notification. And the last one is the detail required to display on the flow meter, which has to be clearly and indelible. The first one, a year of production. Second, the minimum flow rate and the maximum flow rate. Third, the maximum pressure at which the meter can operate. Fourth, the length of temperature at which the meter can operate. 5, the length of viscosity or the type of product as used. 6, the minimum measured quantity. 7, the latest operating condition. And the last one, in the case where there are other limitations, the display of such limitations shall be made. And for the term of verification for the Coriolis mass flow meter is 2 years, which is be required to be verified by Cbwm officer. Why if the repairer is the person who verify the meter, the term of verification will be shorter. It's about 60 days. So this is the legislation regarding the Coriolis mass flow meter. Anyone has questions regarding the legislation, please feel free to ask. Thank you.
Hi, Benji. This is Javier from Singapore here. Can you hear me? Okay, great. Just a quick question for the terms of verification of 2 years. Just wondering how these 2 years come about. Why not 1 year, 3 years, 4 years?
Sorry again, please. So for the term of verification of the mass flow meter, usually 2 years.
Oh, okay. Yeah, I just wondering how is it decided 2 years? Like, is there some background? Or it's just like by legislation in 2 years? I'm just wondering.
I'm wondering if maybe Philip could give an answer to that question as a general overall, so it's not specific to an economy. Are you there, Philip?
Yes, I am.
Well, thank you. That'd be lovely if you heard the question. You heard the question?
I have heard the question. Yeah, no problem. I think this 2 years is just a definition made by the by the national legislator. These 2 years of verification period is the same in Germany too, but as far as I know, it's not the same in each and every country. So it is indeed up to the economy who is setting up the national laws. And obviously Thailand has decided to define a verification period of 2 years. It is sort of a let me call it values of experience.
All right, yeah, I got it. Thanks for the answer. Philip.
Yeah, is that
Yeah.
okay for you?
Yeah, that's great. Excellent. Thanks, Philip, Benji, and Mariam.
Okay, I would like to make some additional comment on Thailand. So, as Philip says, it depends on the national legislations. And for Thailand, we use 2 years for like almost all of our weighing and measuring instrument for the term of verification. That's all. Thank you. Any questions?
Hi, I have a question from Vietnam. Yeah, thank you for nice presentation. I have one question about MMP. How do you determine MMP value for valid verification? How do we determine MMP value?
So,
Minimum measure quantity. Yeah.
I think this is also a question that I might answer, Benji, if you don't mind.
yes, go on.
May I jump in?
Yeah, sure.
Well, the minimum measured quantity is a characteristic value of each and every single measuring system. It is a value from which quantity upwards a measuring system is expected to be correct within the MPEs, within the maximum permissible errors. Suppose a very big system, it is impossible to measure accurately with very big meters if you want to measure small quantities. So the smaller a meter is, the smaller MMQ can be set. And if the meter becomes bigger, MMQ will become bigger. But it is a characteristic of each and every single measuring system.
So it's usually
It is not allowed to measure, generally speaking, it is not allowed to measure quantities below MMQ, because below MMQ, the percentage error might become too high.
and so Philip, it's set at patent approval, isn't it?
I think so. Yeah.
It's in the certificate, I believe.
Tức là nó liên quan đến việc xác định sai số. Thank you for the answer question. But what is the general value for MMQ in Thailand?
Okay. So for Thailand, actually it depend on the type of the liquid that we use for the flow meter. So typically we use 1.5 to 2 liter for the fuel dispenser at the petrol station.
Okay, thank you.
May I give an addition to this? If you have implemented R1 OIML R117, there's a requirement in there for petrol stations that MMQ shall not be greater than 5 liters for petrol stations, in order to make petrol stations suitable for the intended use. But Benji is right. It depends on the size of the measuring system. For petrol stations, it is what did you say? 1 or 2 liters? I think it is.
1.5 to 2.
Yeah, this is a typical quantity for MMQ. In Germany, it is it's either 2 or 5, but it is pretty much. It is quite similar. Yeah. But if the systems become bigger, MMQ would also become bigger. Yeah.
Okay. So Mr. Samrat already raised hand. So please, Mr. Samrat.
Okay, can you hear me clearly?
Yes.
Okay, can you just move a little bit to slide the term of verification? Yeah, actually, I just want the second point, the 60 days verified by the repairers. So in here, I just want to know that after the Cbwm verifies and Cbwm found there is the error to the instrument which is out of the MPE. So at the time the Cbwm allow the repairer to repair it and then verify. Please just clarify this. I just wonder this. Thank you.
Okay, so the second case is for the short term of verification. If actually we can designate the manufacturer of the instrument to be the verifier. Actually, it's not verified by the repairer, it should be verified by the manufacturer of the flow meter. So if you cannot appoint us to be verify the meter on time, you can you can submit the request to be the verifier by yourself, but the verification period will be shorter compared to the verification by Cbwm officer. So this second case is only for the case that you have like in rush in the verification. That's all. This is not the case for the repairing something like that. So if the meter is broken, you have to call the repairer to fix it first, and that repairer shall submit the request for the verification to make the Cbwm go and verify by ourselves. Yes. But if you don't need to wait for a long queue, you might submit the request to have yourself to be the verifier, not for the repairer. Do you understand me?
Okay. Yeah, I got it. Thank you.
More question regarding the morning session. So if there are no questions or suggestions, or we will move to some exercise for you for this today morning. Okay, so for this morning, we have some game for you to play to make all of you relax and have some challenge for yourself. So now we already put the name of the economy. So this is called the wheel of fortune. If I click the spin and the wheel stop at any of your economy. So please share your experience regarding the flowmeter, any kind of flowmeter. You can say something about the Coriolis or other type of flowmeter. It depends on you. So I will spin the wheel, and if your economy was choose, so please send your representative from your economy to play the game with us. Thank you. The first economy that was selected by the wheel is Brunei Darussalam. Please send your representative to play to share your experience about flowmeter with us. Thank you. Mr. Nison. Mr. Nison. Would like to share some of your experience about Coriolis flowmeter?
Hello, everybody. For Coriolis Flowmeter, at the moment, we haven't have any. We have customers who have 3 Coriolis Flowmeter in Brunei, but in the moment, we haven't started doing anything. Usually in Brunei, we select a third-party vendor which is qualified to do it. Majority our vendor comes from Singapore and Malaysia, so they're doing it for us. So we just accept their report and we transfer knowledge to the economy from Malaysia or Singapore. Depend on the vendor. All right, thank you.
Okay, thank you. Any representative from Brunei would like to share more experience about the flowmeter or the Coriolis one? Mr. Muhammad Afif Wafidin.
Hello. I think in Brunei we quite similar. All the inspector doing same thing with the regulation. In same regular and same law. As like Nixon said that we use vendor also for some from Singapore and Malaysia. It's almost the same.
Thank you. So maybe we move to the next economy, the next lucky economy one. Brunei again.
Brunei again. New times Brunei.
Malaysia. Okay, so please send one of your representative to sharing about the flowmeter or the Coriolis, because Brunei already mentioned that a lot of Coriolis are import from Malaysia, right? So maybe you can share some of your experience about the Coriolis flowmeter. Thank you. Hello, Malaysia. Anyone from Malaysia? Please. Mr. Kairu Aswadi, are you here? Yeah. I didn't hear you.
Okay, can you hear me?
Yes, yes.
So for me, in Malaysia, we have a few calibration lab. So I've been witnessing the calibration of the Coriolis meter. And beside the lab, sometime we witnessing the calibration of the Coriolis in factories such as Emerson, in Nanjing, and also in Singapore. So there are some requirement to follow. Depends on the lab and the owner requirement. Mostly the Coriolis used for liquid flow. So I think that's all to share with you guys.
Thank you for your sharing. But I would like to ask you some question about the regulation regarding the Coriolis flowmeter. Are you also have the maximum permissible error indicated in your regulation also, right?
Yes. But I couldn't remember the number clearly since it's already sometimes being to witness the Coriolis.
Okay.
So I need to check back the MPE that we are practicing here.
Okay. So how about the term of verification of the meter?
Again?
The term of the verification period of the meter that you verify.
If you are using for legal, so it is once a year.
Once. Oh,
Yeah,
okay.
once a
Yes.
year.
Thank you.
And for the MCM, we have MCM like inspector. So the requirement will be every 6 months.
So it's different from, it means that the government require at least 1 year, but MCM inspect. Oh, okay. So MCM inspect every 6 months, right?
Yeah.
And the 1 year is verification period.
Yes.
Thank you.
Okay.
Any more representative from Malaysia to add more information about flowmeter or another type of flowmeter apart from Coriolis? Mr. Muhammad No Tafa, could you please share some of your experience regarding the flowmeter? Apart from the Coriolis, any type of flowmeter?
Hello, do you hear me?
Yes.
Okay, actually, my colleague, Mr. Coriolis already explained. Actually, we not have any capability to do this Coriolis mass flow meter. And also, we do witnessing for verification of this Coriolis mass flow meter. Maybe in more gas lab in Singapore and other third party. I think mostly we followed OIMLR 117 for the MPE, around 0.5%. And then that's all I know.
Okay, thank you.
Welcome.
So, anyone would like to make more comment on the experience sharing that we heard from our friend? Okay. Otherwise, I will select the last lucky economy to share experience about Flowmeter. Christine. So the last economy, the last lucky economy for today game is Singapore. Please, representative from Singapore.
Yeah, hey, hi, Benji, Xavier here. Yeah, so for Singapore, the Coriolis mass flow meter, I think just like Malaysia is regulated under legal metrology, and then is mostly used in the sea bunkering trade. So all the ships that's doing all the bunkering, they need to install the Coriolis mass flow meter to do trade transaction of the fuel oil. So and then in terms of verification frequency is yearly, and of course the MP will follow the MP that's similar to OML recommendation, which is 0.3% for the meter and 0.5% for the system, I think, if I recall correctly. Yeah. That's all I have to share regarding Singapore use of Coriolis mass flow meter.
Okay, thank you. Could I ask more about the Coriolis meter in Singapore? Do you do the type approval for the meter also?
Yes, we do have to make sure that the meter is type approved, but we don't conduct the pattern evaluation test in our laboratory because we don't have the capability to do so. So for Singapore, the type approval is just based on having an OML certificate of conformity, which is usually the supplier will get it from overseas laboratory, for example, NMI 13 in Netherlands. Yeah.
Thank you.
Thank you.
Any more representative from Singapore would like to comment or make additional sharing experience? Mr. Andrew, are you here? Mr. Andrew from Singapore.
Hello. Hi, yeah, I think nothing much to add on to Xavier. I think he already explained Singapore's experience. I think basically for meters now currently we are using mainly in the marine bunkering industry, and it's mainly in the marine bunkering industry. Then we also have a few meter vendors in Singapore, some of which are also designated as the authorized verifier. Yeah, so in terms of the type approval, currently we don't have a local test lab, but we recognize the overseas ONR certificate for the MFM before we actually accept them for type approval. Yeah, thank you.
Okay, thank you. Philip, do you have any suggestions or comment or any experience to share among ASEAN? How do you do the Coriolis Flowmeter test or verification in your country?
No, there's basically nothing to add from my side. We also use Coriolis meters in Germany, as well as throughout entire Europe. They run pretty stable throughout the time. That's the experience that we have made. One big issue is the manner of installation. So if a Coriolis meter is properly installed, they run pretty well. That's pretty much the experience that I have made, and we use it for basically almost all types of liquids. Yeah, they're becoming more and more popular. They have become more and more popular the last 10 or 20 years. Yeah.
Okay.
And the requirements are pretty much the same according to OIML R117. Yeah, we have basically implemented R117 in Germany as well as entire Europe. There is a harmonization in Europe, so the rules that are applicable for Germany are as well applicable for Europe.
Okay, thank you for sharing. So I think in the morning session, so we learn more about the Thailand measurement system and also what is Cbwm, what is the regulation of the Coriolis Flowmeter from us from Thailand. And I would like to inform you that we will break at 11:30. So 15 more minutes from now on, and we will come back around 1 p.m. But before that, I would like to inform you that in the afternoon session, our trainer, Mr. Kampana, will go over the construction of the Coriolis Flowmeter. He will present you the history of the meter, the Coriolis effect. So you will learn more about how it operates, how the meter operations, and what is the typical construction of the Flowmeter. And he also give and briefly introduce you the basic concept of the designing and selecting of the Coriolis Flowmeter, how the manufacturer design the Flowmeter and how it should be selected to be used in any kind of the condition, and the performance and the limitation of working of the Flowmeter. And the last session will be the participant feedback and closing, which will be organized by Marian. So again, if you have any questions, comment or concerns, please feel free to ask or send your request, suggestion or comment or questions also through the chat box. Or if you would like to ask, feel free to ask via chat box first, and we will try to bring all of your questions for the trainer to answer. So I will ask you again if you have any questions for the morning section. If you have, please feel free to raise your hand now, and I and my team will answer your question. Thank you. So if no more questions, no more comment, no more suggestion, please be back here around 1 p.m. of Bangkok. Thank you. Okay, well, welcome back everyone to the afternoon session. So in the afternoon session, as I mentioned before that our trainer will be Mr. Kampana Gutasin. And he will go through the construction of the Coriolis Flowmeter and the basic concept of the designing and selecting. So I would like to welcome Mr. Kampana. Thank you.
Good afternoon, everyone. Can you hear me?
Hi. Yes.
Okay. Good morning, everyone. First of all, I would like to introduce myself. My name is Kampana Ditasin, Director of Weight and Measure Center, Thailand, Thailand. Today, we are going to share our knowledge on the Coriolis mass flowmeter. Wait. Share screen. Okay.
เขาเปิดไฟก่อนแล้วนะ
Okay.
เปิดไฟก่อนแล้วนะ
Okay, today the main topic are as follow: 1, history, and 2, Coriolis effect, 3, theory of operation, and typical construction.
Mr. Kampana, could you please unmute your microphone?
Okay, sorry. Okay, construction of a mass flowmeter consists of history, Coriolis effect, theory of operation, and typical construction. Okay. Coriolis mass flowmeter is a flowmeter that measures mass instead of volume of liquid. This type of mass flowmeter that has developed to be used in a wide variety of various industrial applications for more than 25 years.
The main characteristic of this flow meter which made it widely used is because it does not depend on factor or failure of a liquid being measured. While at the time, its flow meter are affected by density, velocity, viscosity, pressure, and or temperature of the liquid being measured. Mass flow meter measure the mass of a liquid while the liquid is following through the meter sensor. With this unique characteristic, we can use this type of a flow meter to measure various type of liquid without calibration or adjusting compensation value or adjusting corrective value because of changing of a factor of failure of liquid being measured. Okay, before getting to know more about mass flow meter, we should understand the general fundamental of the mass flow meter. There are three operational principles to measure mass flow rate as shown on the slide. 1, influential principle, 2, thermal principle, and 2, mass flow principle. Okay. First, mass flow meter using influential principle. This time of a flow meter is used to measure flow rate by volume together with measuring density of liquid. Then input value in this equation, this advantage of this principle of that we must install it. Additional equipment such as density meter, pressure gauge, thermometer, and a flow computer with closely and measurement results sometimes contain a lot of error. Okay, in the thermal principle, we
Mr. Amanda, sorry. We have a technical problem. Just wait a second.
Hello. Hello. Hello, everyone. You hear me?
Yeah,
Hello.
Yes,
We can hear you.
Yes, but the host has some technical problem. Just wait a second.
Everyone can see the slide.
We can't see the slides right now. So just wait.
Just try to share the slide again.
Okay.
เอาเป็นแชร์ในจอไงเขาเป็นแชร์สกิลลองดูอะไรเขากดได้แล้วโอเค
Hello.
Yeah, so Mr. Kamanan, you can continue your course. Thank you. Sorry for the technical problem.
Hello.
Yes, we hear you.
Okay. In the thermal principle, we skip. Okay, true math flow principle. Okay, everyone can see the true math flow meter principle. Hello.
We can
Yes,
hear you, and we
can see the slides.
Can see the slide and we also hear you.
So off you go. We're ready.
True math flow principle. Okay, I will the flow meter using a true mass flow principle, using principle of analytic of a result of the rotation, movement, and a radial motion of liquid. This time is the movement of liquid made Coriolis acceleration and Coriolis deceleration from force of the liquid to the meter. This force is changed along with mass of the liquid which flow through meter. Thus, flow meter that using Coriolis principle is considered to be true mass flow meter, since the meter using characteristic of mass to measure mass. Moreover, this type of flow meter is easily used and not too much large. Operation process of the meter is not involve motion, rarely maintenance, and frequency calibration not required compared to other type of flow meter. We can choose appropriate various material for part of a meter that have to be wet all the time. The material of that part have to tolerate corrosion and erosion. Moreover, the Coriolis mass flow meter can be used to measure density of liquid while measuring mass flow rate based on relationship between liquid that could flow in one component and two component flow stream. For Coriolis flow meter sensor, we could decide to be used in highly dangerous zones such in the oil refinery area. Okay, Coriolis, next topic, Coriolis effect. Okay, Coriolis effect, everyone can watch on watch on YouTube about 240 minutes. At the moment. Stop at the channel. Wait a minute for video.จะขึ้นแชร์ใช่ไหมโอเค
Picture a circle. Here's a center, here's point A, and here's point B. Point A is twice the distance from the center circle and point B. Point A extends from the center. In 2 seconds, both points do one full revolution. But to go all the way around, point A has to go this far, while point B only has to go this far. And although something travels a greater distance in a shorter amount of time, it must be going faster. So point A must be going faster than point B. Okay, now swap out this flat circle for the Earth, and this continues true. All points closer to the center, say like something Greenland, will be spinning slower when compared to points spinning further away from them. Say like people in Brazil, closest to the equator. So if we look at it all the time now, we can picture something like this. Arrows at the equator travel faster than arrows at the 45-degree line like we just observed. Now imagine there are clouds that form here on the equator. You'll have the same velocity as the Earth, but then because the wind sweeps you to the north, when the Earth isn't spinning as fast. Usually, your speed remains the same. You don't get any faster, but everything around you is literally traveling slower. So you, relative to the ground, move ahead of everything else. If you're on the 45-degree line, you'll also have the same speed as everything around you. But if you jump down from the equator, you'll be moving slower than the ground underneath you, so you'll fall behind. And the same thing for the other hemisphere. Moving towards the equator always results in falling behind, while moving away results in pushing ahead. Okay, now let's show low pressure cell. That means all the air around it will be sucked into the center. But the air coming from the equator will be traveling faster, so they will deflect to the right, while the air coming from the poles will be moving slower, so they'll fall behind and deflect to the left. What this results in is a circular air current spinning counterclockwise, and that's exactly what hurricanes are. Low pressure cells spinning because of the Coriolis effect. Moving this example down to the southern hemisphere, things are reversed. A low pressure cell will still suck in this amount of air. Now the air coming from above will be moving faster, again, moving to the right, while the air coming from below is moving slower, again, falling behind by moving to the left. This results in a clockwise spin, which is why storms in the southern hemisphere spin this way. That's all right. In the short video, that's kind of the point. I hope you got the beginning for it. The Coriolis effect doesn't really influence fluid, but just really too small. And the direction of the spin will depend on the place within chest inside the fluid. That's it. That's the Coriolis effect. If you want to shorten to the point where you can feel like it, if you want to see what it is like, I'll be back next week for another video. So until then, thanks for watching.
Okay. Next, theory of operation.
Excuse me. Mr. Campana, can you hear me? Mr. Campana, can you hear me?
Yeah.
Okay. So I think the video that you just play is the sound is not quite good. So maybe I can the host can open the video again. Okay.
Okay.
Yeah. Okay. So we will open the video link again for everyone. Okay. Sorry for that.
Okay. Coriolis effect. We can watch. We can watch video again.
Picture a circle. Here's its center, here's point A, and here's point B. Point A is twice the distance from the center of the circle than point B. Oh yeah, and it spins from its center. In 2 seconds, both points do 1 full revolution. Picture a circle. Here's its center, here's point A, and here's point B. Point A is twice the distance from the center of the circle than point B. Oh yeah, and it spins from its center. In 2 seconds, both points do 1 full revolution. But to go all the way around, point A has to go this far, while point B only has to go this far. And we all know if something travels a greater distance in a shorter amount of time, it must be going faster. So point A must be moving faster than point B. Okay, now swap out this flat circle for the Earth, and the same thing is true. All points closer to the center, say like someone in Greenland, will be spinning slower when compared to points spinning further away from it, say like people in Brazil, closer to the equator. So if we look at it all flattened out, we can picture something like this. Arrows at the equator travel faster than arrows at the 45-degree line, like we just observed. Now imagine you're a cloud that formed here on the equator. You'll have the same velocity as the Earth, but then a gust of wind sweeps you to the north, where the Earth isn't spinning as fast. Due to inertia, your speed remains the same. You don't get any faster, but everything around you is literally traveling slower, so you, relative to the ground, move ahead of everything else. If you're a cloud that forms at the 45-degree line, you'll also have the same speed as everything around you, but if you drift down to the equator, you'll be moving slower than the ground underneath you, so you'll fall behind. And the same things for the southern hemisphere. Moving towards the equator always results in falling behind, while moving away results in pushing ahead. Okay, now imagine a low-pressure cell. That means all the air around it will get sucked into the center. But the air coming from the equator will be traveling faster, so it will deflect to the right, while the air coming from the poles will be moving slower, so they'll fall behind and deflect to the left. What this results in is a circular air current spinning counterclockwise, and that's exactly what hurricanes are, low-pressure cells spinning because of the Coriolis effect. Moving this example down to the southern hemisphere, things are reversed. A low-pressure cell will still suck in the surrounding air, but now the air coming from above will be moving faster, again deflecting to the right, while the air coming from below is moving slower, again falling behind by moving to the left. This results in a clockwise spin, which is why storms in the southern hemisphere spin this way. And that's about it. It's a short video, and that's kind of the point. I hope you got what you came for. And the Coriolis effect doesn't really influence toilets, they're just really too small, and the direction of the spin more depends on the placements of jets inside the toilet. But that's it, that's the Coriolis effect. If you liked this short and to the point video, give this video a like, and if you want to see more videos like it, why not subscribe? I'll be back next week with another video, so until then, thanks for watching.
Okay. Okay, next theory of operation. We will watch the video. Excuse me, Benji.
Could you send me a link? Please send the video link to where the Zoom chat box. Okay, okay, Mr. Kamana, I already got the link, so the host will share the video link for you.
Okay, thank you.
Thank you.
The most diverse substances are transported and distributed in pipelines every single day. This may include drinking water, fruit juices, oil and gas, as well as chemicals, acids, or alkalis. The fluids flowing through pipelines often display completely different properties. Consequently, there are different principles for their measurement. One such method is flow measurement based on the Coriolis principle. The French physicist Gaspard Gustave de Coriolis set out the physical basis for this measuring principle over 200 years ago. What is interesting is that the Coriolis principle allows the flow of mass to be directly measured. Let's take a closer look at how this measurement method works. A tube is located inside each Coriolis flow meter. An exciter causes this tube to oscillate constantly, here in an exaggerated example. If there is no flow, the measuring tube oscillates uniformly. Sensors are located at the inlet and outlet and register this basic oscillation precisely. As soon as the fluid starts to flow in the measuring tube, however, additional twisting is imposed on the oscillation as a result of the liquid's inertia. Now, due to the Coriolis effect, the inlet and outlet sections of the tube oscillate in different directions at the same time. The highly sensitive sensors pick up this change in the tube oscillation in terms of time and space. This is known as the phase shift, and is a direct measure of how much liquid or gas is currently flowing through the pipe. The higher the flow velocity, and thus the total flow, the greater the deflection of the oscillating measuring tube. The application of the Coriolis measuring principle doesn't stop here. It can also be used to simultaneously determine the density of the flowing fluid. To do so, the sensors also register the oscillating frequency. In other words, how often the measuring tube moves back and forth in 1 second. From the animation, it's clear that a tube filled with water oscillates more frequently than a tube filled with honey, for example, which has a far higher density. Thus, the oscillating frequency is a direct measure of the fluid's density. Both the density and the flow are determined simultaneously but independently via the tube oscillation. Endress and Hauser has continuously revolutionized and perfected Coriolis flow measuring technology in numerous innovative systems. This measuring technology is unique, as it's the only way multiple process variables such as mass flow, volume flow, density, temperature, and even viscosity can be measured simultaneously in pipelines. For all applications, we have the right solution. Endress and Hauser, your single source supplier for measuring technology.
Okay, everyone can see the slide. Theory of operation.
Yes, we can see the slide.
Okay, thank you. Okay, next. This theory of the mass flow meter. Okay, this picture is a Coriolis force, centrifugal force, and other force. The theory of operation of a mass flow meter is information. Of information on design and construction mass flow meter. Coriolis force. Coriolis force F is equal mass multiply 2 and angular velocity multiply average fluid velocity. Actually, in the theory, I think it's necessary for design mass flow meter, but I think participant, I think we want to know calibration, we want to know verification, and want to know okay, sorry. Typical construction. Okay, construction of a mass flow meter. Sensor unit or tube sensor, vibrating measuring section. Begin with the first part. Sensor unit or tube sensor or vibration measuring sensor. This part or this section of Coriolis flow meter is very important for operation of the Coriolis flow meter. and could be guarantee highly accuracy and appropriate for work. This part is consists of okay. Measuring tube or flow tube with is a tube in U or omega or any shape illustrated in the slide. Depend upon time of operation, in fact, shape of the tube, in fact, pressure drop. Since the specific frequency vibrate the measuring tube. Why at one end of the tube is a tighten. The stiffness of a tube is an important thing to consider. When period of a vibration or length of a movement of a measuring tube is high, the stiffness of the tube should be high too. In some case, stiffness of the tube could be reduced by increasing length of the tube, which make the tube has a various shape as illustrated in this slide, and decreasing the overall laying length, but the pressure drop or pressure loss is high since the liquid flow through the tube. Okay, this shape of a mass flowmeter. Cantilever tube, project loop, and a strength tube. Okay, it's a many shape. Okay, measuring tube or flow tube is a part that directly contact liquid. The tube is made with a material that corrosion resistant. Mostly the tube is made with a seamless stainless steel 316 or 316L tube that coated with a non-metallic substance such as a type cell inside. Moreover, the tube might be made with titanium, alloy, and titanium instead of stainless steel pipe. When stainless steel pipe could not resist the corrosion. Okay, this picture of measuring tube. Okay. The flow splitter in case that the Coriolis mass flowmeter consists of two tubes. This tube of flowmeter has an advantage in decreasing impact from outside vibration force to disturb on the operation of this flowmeter. Our tube sensor will be connected to flow splitter. This splitter will connect to the flow rate measuring system and do split liquid that flow into the flowmeter into two equally. Sorry. Okay, all tube sensor will be connected to flow splitter. This splitter will connect to the flow rate measuring system and do split liquid that flow into the flow meter into two equally sections in order to let them flow to these two tubes. Then combine these two sections of a liquid that flow out of the tube and return them to the flow tube system as follow mostly in the design process. To design some type of a flow meter, straight will be found at a highly allowed connection between measuring tube and a flow splitter. For this above reason, Coriolis mass flow meter could measuring flow rate into two different directions. To do this, we shall switch some Y inside RFT. Okay, this picture of a flow splitter. So I think this picture is a mass flow laboratory. Drive coil is send a signal for the right position detector and left position detector. Okay, drive coil is installed allow the center between two measuring tubes by installing one vibration source into one tube and install opposing magnet on another tube in order to make both tubes vibrate, and natural frequency which is about 180 degrees of a different vibrating phase for decreasing vibration of mass flow meter system, which make a balance inside sensor unit. The motion sensor or peak of coil and a magnet will be installed at both tube leg at inlet and outlet in order to the sensor motion of these two legs of a tube in both sides. Most motion sensors are electromagnetic, but some manufacturers develop optical sensor instead of electromagnetic. This motion sensor will censoring motion of tubes is a transmit signal to electrically compared to determine Coriolis twice. For micromotion in flow meter, there will be two sets of a motion sensor at the two legs of tube at both inlet and outlet. Why is it consists of magnet and coil? When installing magnet with one tube, coil will be installed at another opposite tube in order to censoring motion. Both magnet and coil will relatively move when tube twist because of liquid flow through the tube with simulate to vibrate and at natural frequency at steady frequency all the time. When coil move forward and backward, cause the uniform field of magnet, which create a induction of a alternating electric current inside coil. When drawing graph illustrate a relationship between inductance of an electric potential different inside coil, comparing period of time when seeing through oscilloscope. The shape of graph is like in a sine wave. Graph is like a sine wave. Everyone, you know sine wave? Okay, sine wave. Everyone, you know electricity have a sine wave. Yeah. Okay, temperature sensor. Flowmeter has a temperature sensor installed at outside surface of one of tube in the system. Mostly installed at tube nearly inlet with temperature sensors such as resistant temperature detector or RTD. Resistant temperature detector, RTD. Tied by input field voltage at a specific value to the RTD and continuously measure electric resistance by using the principle that the electrical resistance of the medium will change along with temperature, so that the voltage that changing because of the electric resistance could indicate temperature of that tube. Since the stiffness of tube and could be measured in a modulus of elasticity impact tube in a twisting. When liquid flow through the tube, it is simulated by a natural frequency at steady level, also called Coriolis effect, including rigidity of a tube could be measured in from the modulus of rigidity, so that this value impact natural frequency of vibrating of tube. Okay, casting of mass flow meter. Casting of a mass flow meter has a main role in protecting measuring tube, flow speeder, dry coil, motion sensor, and a temperature sensor from outside environment with my effect operation of the flow meter or corrosion of one of these components. Typically, casing must be made of stainless steel. Okay, electronic unit. In a signal wiring process for motion sensors, temperature sensor, and a power line to the drive coil inside the measuring unit. The wire will be go across casing that must completely be sealed to protect it from any sparkle while the operation, or at least be according to electricity standard using in the workplace. Besides, signal wire out of the electronic unit, there is a electronic transmitter or remote flow transmitter. Okay, is a so-called RFT. RFT, this transmitter is all signal receiver which will computing or transmitting signal to electronic unit, which will be located far from location that flow meter is installed, depend upon program that is set before. However, distance between electronic unit and electronic transmitter is a limitation that is needed to take an account. If a signal wiring distance is beyond the specific distance, loss of signal from sensor will occur. Okay. If any participant is not understand, you can come back to learn more again. Okay, next electronic unit. You know, some companies specify distance between measuring unit and electronic transmitter shall not more than 250 meters or 800 feet. Not more than 250 meters. Okay. Okay, this this line is FT consists of a chip, consists of main board, and I don't know in the detail, but you can learn more. Since the operation of the flow meter inside of the sensor unit need power in order to create a vibration to measuring tube. They shall have an electric wire and a signal wire connected between sensor unit and electronic unit. But mostly electric power wire is needed to be separated to sensor unit. In fact, mass flow meter placing in the market nowadays could be found both operating with a direct current electric, okay, DC, direct current, and alternative current electric, AC. This type of mass flow meter need power allow 10 watts in operation. However, information from a manufacturer is needed to take in account in order to ensure accuracy. Electric unit has an important role in controlling vibration of measuring tube inside sensor unit. Such the measuring tube is vibrating at natural frequency in steady rate across the measuring length. Moreover, the electric unit also receives a signal from sensor unit and convert to standard signal before sending the signal out. This output signal could be in analog form at size of 4 to 20 milliamp, or pulse frequency, which could be transmitted to other equipment such as a controller or indicator and a totalizer. Okay. Okay, I think the last page, the last slide. Mass flow meter could be found in the market nowadays in a design in order to be used in hazardous areas such as oil refinery area or chip is a floating area or petrol station. Thus, sensor unit could be designed to be used up to DIVI level, while IFT could be used up to DIV2 level, according to IEEE standard. However, we should consult with the manufacturer before buying the mass flow meter. To summary, main role of a Coriolis transmitter or remote flow transmitter, so-called RFT, are as follow. 1. Receive signal and process signal from sensor unit. 2. Transmit the result to other operated equipment such as controller and or indicator and a totalizer. 3. Transmit electric power to sensor unit to simulate and maintain vibration condition of a measuring tube at natural frequency, which means that when density of liquid change, natural frequency of a vibration of a measuring tube also change. Thus, there is an automatic controlling system to increase or decrease the vibration frequency of a measuring tube. Okay, in this section, anyone have question? If a question? Okay, next. Basic concept of designing and selecting. We have three main main topic: designing, performance, and limitation of working, and selecting a mass flow meter, designing of a mass flow meter. Okay, everyone. We will break, coffee break, 30 minutes. Okay, and after that, we.
Can I just say something? There's no coffee break on the agenda.
Marian, okay. Not coffee break.
No, sorry.
Yeah. Okay.
Otherwise, we'll go too long.
Okay.
Sorry, so.
Any participant, you can bring a coffee.
Yeah.
and listening me to. Okay, next. Designing. Normally, Coriolis force has a very low impact on two systems. That is similar to a vibrate dust. If we measure mass flow rate of a mass flow meter at a capacity, typically measuring tube will twist about 1 to 1,000 inch or 0.001 inch or 0.025 millimeter, which is considered very few. Or in case that that measuring length in 100 to 1, it is needed to trace at a less about 0.000012345 0.00001 inch or 0.25 micrometer in order to make a reliable measuring result. Thus, in order to get accurate and reliable measuring result under condition that the meter will be used in the industrial area, sensor must have to be designed, developed, and tested under environment that regularly change. Whatever density of a fluid, temperature of fluid or environment, vibration from flow meter itself, or outside and other factor. In conclusion, if sensor is well developed, this type of flow meter will be reliable and product accurate flow rate measuring result. Okay, designing. designing in a designing process, we may face many issues either directly or not from many factors involved, such as tube material, tube shape, and the thickness of a tube wall. These factors are the main factor that product form of signal. For example, different type of a tube material product different spring constant. Thus, the longer measuring tube that is blended, will be more foul than the shorter. And strength measuring tube. Why thicker tube wall have a small change to loss its shape compared to the lighter ones? Why tube diameter, length of tube, and the radius of bended tube is the main factor that impact pressure drop of flow meter. Okay. Safety. Safety is consists of hazard area location, materials, and straits. Since safety is one of the important factors that should be considered because resources and life might be lost from this factor. Since construction of a Coriolis flowmeter is need to use electric current, which might cause sparkle. Thus, all electronic devices used for measuring must be designed according to international standards, such as a transmitter must be according to IEEE standard of type DIV I or DIV2. Sensor material. Since principle of operation of Coriolis flowmeter is vibration of measuring tube, which is only movable part and is needed to be careful of safety because the measuring tube might break or leak. Fatigue stress of a measuring tube is an important factor in designing tube. Fatigue strength is the ability of material that resistant to break or deteriorate loading. Ability to resist from that force of a stainless steel. And Hastelloy C22 alloy as shown in the slide is a maximum bodily of 2 times. In the slide is a maximum bodily of 2 times of material. That endure cyclic loading, just measuring tube is made of this type of material will not break or damage due to straight from vibration that within boundary. Okay, next. State due to vibration of a measuring tube depend upon movement of a vibration or shape of a measuring tube. Some manufacturers provide equipment to limit vibration length inside sensor unit in order to protect measuring tube to be damaged at the beginning and ending of a measuring tube operation with is the length that severely change in the frequency of a vibration. From this reason, stainless steel and alloy that has high nickel is having characteristic that highly endure the cyclic loading. Moreover, physically characteristic could impact the failure characteristic of a tube under vibration. Curve illustrate in this slide show interesting information that after experiment boundary of endurance characteristic to cyclic loading depend upon wall thickness of a tubing, which means that if the wall is thickened, the boundary is also increasing. Okay. This slide is the this material. This is a class of a standard in the other country. ANSI. DIN is mean Germany, and JIS Japanese Industrial Standard. Okay. Casing of a sensor unit should also be designed to have sensor to detect designing electronic current to detect smallest signal is a process you should mostly concern. Since delta T signal is a variable and an important signal in a measuring flow rate of a mass flow meter, which has a value in a nanosecond length. At once, nanosecond is time of electronic signal that could move allow 30 centimeter or 1 feet in a conductor, which means that we should concern the delay in signal transmitter to wire print circuit board, conductor, and a logic gate in order to accurately measuring time length of delta T, including protecting source of electronics which might disturb or signal. In addition, process of transmitting signal, including filtering signal, also should be concerned. Okay, performance and limitation of working. Performance and limitation of working in the market. In the market, there is a various size of mass flowmeter to be selected from 1/16" to 6" with a flow rate from 2-3 grams per hour to 10 tons per minute. Coriolis mass flowmeter is categorized as a linear flowmeter. Since mass flowmeter views signal after output of a flow rate, measurement is almost linear compared to the mass flowmeter. Or we could say that flowmeter is type of flowmeter that provides signal after measurement that is not proportional with the flow rate. Squat sorry. This type of a flowmeter that provide signal after measurement that is not proportional with the flow rate. Squat divided with test fluid density. Thus, flowmeter could be used in various fields. Typically, Coriolis flowmeter have a measuring length of 25 to 1 to 100 to 1, while providing accurate and reliable result in some type of operation. Accuracy. Accuracy of a Coriolis mass flowmeter range from plus minus 0.15% until plus minus 0.25% at its flow rate, plus at a zero shift error, also called zero stability, from some manufacturers. A zero shift error is a small shift value of sensor unit. An electronic device. For these reasons, most manufacturers usually set uncertainty of flow meter at no flow or at flow rate equal to 0. Is a percent of the meter capacity of the sensor unit. This uncertainty will be combined with accuracy and will be part that impact to accuracy of a measuring rate. Especially at the lower end of the flow rate. Repeatability of a mass flow meter range between 0.03 and 0.05%. However, this value will be higher or lower than this depend on manufacturer. Yeah. Okay. Next slide is an example for Coriolis mass flowmeter. Everyone can everyone can calculate it. Okay, I think the example Coriolis mass flowmeter. Or we will skip to slide. Okay. Did the slide show a comparison of performance of a Coriolis mass flowmeter in order to get best effectiveness and performance at the lower flow rate as much as possible? Coriolis mass flowmeter has a competent in zero adjust after what installed into tube system. Zero adjustment could be done by let fluid flow Coriolis mass flowmeter until temperature inside tube is equal to temperature of test fluid. Then close outlet and do zero adjustment. However, change of temperature will have some impact to zero offset. Most of Coriolis mass flowmeter manufacturer will suggest to do zero adjust when temperature change less than 10 Celsius of the actual operation temperature. As the type of a flow meter, accuracy of a Coriolis mass flow meter will be impacted if gas or bubble is of foul mixing with the test fluid. Even that gas or bubble is completely mixed with the fluid, Coriolis mass flow meter have to use a little more power in order to make a measure tube vibrate. If gas or bubble mix in the fluid explode, making space inside fluid, performance of Coriolis mass flow meter will decrease because damping of the vibrating tube. That the space is less than 5% of volume of tube. Will alarm because of gas and air mixed with the fluid, so-called surging. Inside a vibrating tube, that alarm will disturb Coriolis twist signal to electronic until, in case that there is a wide space inside the tube could be stopped vibrate since vibration absorption occur because the surging inside tube making drive coil could not drive. Okay. This slide accuracy and repeatability. Bad accuracy, best accuracy, where you plus minus 0.50% of bad and repeatability, plus or minus 0.25% of lead. Okay. This picture is air eliminator installation into flow rate measurement system with the Coriolis mass flowmeter. Is an important and necessary in order to protect fluid flow with gas mixing, which make the flow not steady, sometimes also called slug flow, not impact or decrease accuracy of flow meter. But the way even slug flow occur inside the tube will disturb twist signal and make it lost. The tube still have not been damaged. Okay, everyone, try. Okay, we can detect slug flow by using electronic device or flow meter. In many cases, such as flow meter will increase vibrating fast, or in some manufacturer. Some supplementary device could be introduced to stop transmitting tube twist signal, or alarm when Coriolis mass flowmeter could not measure flow rate at needed accuracy while in slug flow situation. In case tube occur unsteady vibrating because of fluid change, will cause a confused signal and decrease the accuracy of the Coriolis mass flowmeter. In addition, Coriolis mass flowmeter could be used in wire measurement range when using with fluid or wastewater, but will have a limitation when using to measure mass flow rate with gas. Okay. Selecting is a final today. Selecting our Coriolis mass flowmeter. Okay. We consider the flow rate and life side, pressure and temperature rating, wet part and a pressure drop. Flow rate and life side of measuring system is an important factor to set flow meter size by determining. First, nominal bore size of sensor unit should be equal or smaller than life size of the light system that used to install the flow meter. Second, to obtain an appropriate performance. The normal full scale flow rate of the meter should be optimized to the full performance of the meter by allowing pressure drop in acceptable rate. Okay, pressure and temperature rating. Pressure and temperature rating, including method to connect sensor unit with light system of measuring liquid is also an important factor to determine when selecting flow meter. The sensitive pressure rating should be higher than the maximum rate pressure of the line that install Coriolis meter, but we should be careful whether the maximum rate pressure of the flow meter that's specified by manufacturer when using the required temperature range, and also time of operation in a measuring mass flow rate to connecting sensor unit with the light system. All selecting should be met with the maximum operating pressure. To select the Coriolis mass flow meter to be used in a normal operation, we should base mostly on information or instruction from manufacturer. Okay, to selecting an appropriate material and wet parts of a tube. Need to be careful since determining straight corrosion is very hard. Material for the flow meter should be durable to liquid erosion or any contaminate. Moreover, it should not make any reaction to liquid being measured, and not easily to be influenced by chemical and physical factors. In general, the tube that is wetted part should be made by stainless 316L, but still there is a tube made by alloy, Mosnell, titanium, titanium, and anything else. Okay, pressure drop. We can see region 3 that a mass flow rate measuring system designer considers pressure drop of Coriolis mass flow meter as one of an important factors. If a high pressure drop rate is acceptable, erosion is possible because of erosive fluid. The pressure drop could be divided into two cases. One is happen when using the meter to measure liquid, and another is happen when using the meter to measure gas. Normally, pressure drop graph will be given by manufacturer. That graph is a applied pressure drop determination from a Darcy formula. That Darcy formula which is a form of a measuring tube which found that the flow rate length in from the lamina. Orderly lamina flow and a turbulent flow. Everyone, you know, laminar flow is a in the tube is a flow rate is a smooth. It is smooth in the lamina, and the turbulent flow is not smooth in the flow rate. Okay. Pressure drop is directly proportional with the flow velocity and viscosity, while flow rate length in from the turbulent pressure drop is directly proportional with flow velocity squared and viscosity to the power of 1/4. Renault number, actually Renault number, I think I forget because long time ago Renault number is so I learned. Renault number is used to set type of a flow inside a measuring tube, whether laminar flow or a turbulent flow. We will set type of flow to be laminar flow when the Renault number is equal or less than 2000. Turbulent flow is when the Renault number is equal or more than 4000, while setting type of a flow to be a transition flow. When the Renault number is between over 2000 to 4000, typically Renault number is equal to 2000 as a divided value between a laminar flow and a turbulent flow. It's a many slide. Okay. Next slide. Using graph manufacturer to determine size of a flowmeters. Typically of graph is drawn based on a relationship between mass flow rate and pressure drop, which is divided by a specified gravity of process liquid compared to water. Such as the graph is slotted. Here is in mass flow rate of a water unit. The graph oscillates pressure drop of a Coriolis flowmeter of various viscosity of liquid. Okay, this slide in case of need to select meter for measuring height because the liquid, we should consult the manufacturer to select a Coriolis flowmeter for measuring mass flow rate. in addition to pressure drop, we should consider full-scale flow rate, available pressure drop, process fluid viscosity at operating condition, and process fluid density. Okay, this pressure drop for gas. Pressure drop for gas of a trend of gas at a relative low density condition. Thus, change to get an accurate mass flow rate result, then pressure inside tube is lower than 5 bar or 22.5 psig pound per square inch. It's nearly impossible because in the general gas viscosity is less than 0.02 centipoints. Thus, from a gas flow is nearly to be turbulent flow according to pressure drop graph from a manufacturer, which refer to water flow measurement. We could use the graph to predict pressure drop of a flow meter when using to measure gas. Okay. By the way, we should be careful that pressure drop that calculated from above formula is not include pressure drop of two systems that have reducers installed in or out of flow meter, but only pressure drop of a flow meter itself. The figure, this slide is a show example of a relationship between a pressure drop and a mass flow rate of the 25 millimeter size of a Coriolis mass flow meter. Okay, in case of selecting Coriolis mass flow meter to use with a dirty liquid, use with a dirty liquid or slurry liquid, we should specify flow with flow velocity less than 10 feet per second or 3 meters per second in order to prevent erosion to occur at a measuring tube or wet part while measuring. Considering to considering for dirty liquid. Okay, this slide show an example for typical Coriolis flow meter specification. Okay. Okay. End of the end of the movie. Okay. Any participant have a question? Who have some question? Who have question? No. Thank you. Thank you. Thank you. Actually, in Thailand, in Thailand, you know, thank you everyone to listening. Thank you everyone to listen to if everyone not understand, you can come back to learn the slide again. Okay, Marian.
Yes,
Marian.
I'm here.
Yeah.
Thank you, Nin. That was lovely.
Yeah.
I'm hearing myself as an echo, so I hope it's not happening like that for everybody. Seems to be good now. Okay, well, thank you so much that's a very big afternoon you've had doing the 2 hours without a break. I'm sorry to do that to you. And as you said, people can look at the slides again, and it would be really, really good if overnight you had a look at the slides that maybe you didn't quite understand or you want to ask more questions.
Thank you.
And tomorrow when we start, I will give you an opportunity to put some questions up regarding today's slides if you don't have them today. So let me ask, first of all, I'll ask Philip if he's got anything he wants to add, any thoughts he's had on the afternoon. And then after that, I'll ask all the participants to ask questions if they have any questions, or even suggest what they want to hear tomorrow, anything specific that's triggered in their brain while they were listening to it. So Philip, can you go first, please?
Yeah, sure. So the only points that I would like to add is we have seen, I think there was 2 videos, and we do not have, the participants do not have the links to the videos yet. Am I right?
Yes, good point.
Would it be helpful if I put the video links into the chat box so that everybody will be able to wrap up and repeat later on, sorry, at home again, especially because there are lots of explanations, and for those who have seen the explanations for the first time today, it might be helpful to watch the videos for a second or for a third time. The videos are very, very good.
I think Benji might put them. Benji, will you put them in the box?
I'm sorry, Benji has got her hand raised. Benji, it's yours.
Yes, thank you. So I will do the same as in the LPG course, because we put all the video clip link into the Word file and put the file into the PTB box.
Good.
Okay, and the file will be available today in the evening, maybe in 1 hour later from here. Yeah, thank you.
Perfect. That's wonderful. That solves the problem. Thank you so much. And thank you, Philip, for raising it. I did think that when we were listening to them. It was quite odd, wasn't it, that Benji had to play them for them to come through. I mean, the first time I heard the first one, I thought, it's in English and I can't understand a word they're saying. It was like twice as fast.
Neither could I. The audio quality was
weird.
Absolutely under the weather.
Yes, but thankfully Benji and her team came up with a solution, and we listened to it a second time, which was perfect, because it is a good explanation, don't you think? It's quite simple. It's an easy one to follow.
So I'm not going to put the video links now in the chat box, because Benji, you are going to send them out. Did I get that right?
what she's going to do is she's going to put them in a Word document, and she's going to put the Word document in the box. See at the top of the chat, there's the PTB box. So in that PTB box, we'll have everything in one place.
Yeah, okay. Perfect.
Yeah. Good. Anything else, Philip?
No, that was the only idea. These were the only ideas that came up during the during Kumpanat's presentation. And yeah, thank you very much, Kumpanat, for the presentation, for the big job you did.
Yes, it is a big job.
Thank you.
And I think for anybody looking at it for the first time or listening to it for the first time, it's quite complex. So they will have to go over the slides again. But of course, fortunately, they have them, and they're beautiful slides. They're very nicely laid out, very clear. Okay, so now I'm going to say, is there anybody of the participants who has a burning question, please? I can't see hands, so if you just speak up if you want to say something, please. I don't know why I can't see the hands, but I can't. Okay, you're all very quiet. I hope you're all still there and still awake. Okay, Benji, have you got anything else to say?
No.
Okay, well then I think maybe we will close for the day, and we'll start again tomorrow at the same time. And we've got probably even a bigger day tomorrow. There's a lot more complexity in tomorrow than there was today, because we've got the full day of technology tomorrow. So please write up your questions, make little notes if you have questions in the morning. Benji did say I have 15 minutes for opening remarks. Well, I won't be talking to you for 15 minutes. I will be asking you what questions you have. So that little section is going to go very fast if you have no questions. But it's a shame, we're getting Philip up in the middle of the night, so it's a shame not to ask some questions if there's an opportunity to have you know, an expert and Kumpanat as well to answer your questions. So please think about questions.
Yeah, don't worry about it too much. I'm sure I will be able to answer questions in the night.
Okay, so good evening, everybody, and have a very pleasant rest of the day. Thank you. Oh, what about the log on for tomorrow? Sorry, I should have asked that. Is it the same one or a new one, Benji? The Zoom link for tomorrow?
The same one.
Same one, okay.
As today.
Perfect, that makes it very easy. Oh, there, I can see everybody now. Bye-bye, everybody. Thank you.
See you.
Thank you.
See you tomorrow.
Thank you, bye-bye.
Thank you.
See you tomorrow.
เห็นไหมไม่เห็นมองไม่เป็น